In our first module for geometry, we are going to lay the foundation for all of the future modules. So we're going to look at the things that we're going to build all the other geometry concepts off of. So our big ideas in this module are vocabulary, our building blocks, constructions, and reasoning and proofs. We're going to start today with these building blocks. We're going to do a little bit of vocabulary as well, but start today with these building blocks of geometry. So each subject of mathematics has a set of rules that everything else kind of builds off of. For us in geometry, that's our postulates, theorems, and properties. We're going to start with a postulate. I do want you to write this definition down in your booklet on the first page. A postulate, which is sometimes also called an axiom, is an accepted statement of fact. And again, these are the building blocks. These are the things that everything else is built off of. Theorems are things we prove using our postulates. Postulates typically are going to be things where we say, yeah, that makes sense. We're going to look at 4 of those postulates today. Pause if you need to. So our first postulate, through any 2 points there is exactly 1 line. So in this case, and I do want you to write this down here, line T, see the lowercase t, that is one way to represent a line, passes through points A and B, and line T is the only line that passes through both points. So there's not another line that's going to do that. Now, let's chat real quick about some of our notation. Lines can be represented multiple ways, but one of the ways is with a lowercase kind of cursive letter. Points are always going to be capital letters. And again, that postulate, you should be saying, yeah, that makes sense. I knew that already. Let's go to Postulate 2, and again, pause as you need to. Postulate 2 says, if 2 distinct lines intersect, then they intersect in exactly 1 point. So let's take a look at this one. This is another way to represent a line, or to write down, name a line. So this is line AE. So we do the AE, which are the 2 points that it goes through, with the little line symbol overhead. So this is line AE, which is this one, and line DB, which is this one, intersect at point C. So if 2 distinct, that means 2 different lines, not the same line. If they do intersect, then they intersect at exactly 1 point. And again, we should be saying, yeah, that makes sense. Let's move on to Postulate 3. Postulate 3 says if 2 distinct planes intersect, then they intersect in exactly 1 line. So a plane, we'll do our formal definition later, but our plane here is this blue, and our plane is this kind of creamy color. So we have 2 planes here intersecting, and they're intersecting at this line here. So let's talk notation here as well. Planes are named, again, several different ways. One of the ways is with 3 points that are on the plane that are non-collinear. We'll talk about what non-collinear means in just a second. So plane RST, there's R, there's S, there's T. The plane that contains all 3 of those is this blue plane. And plane WST, so there's W, there's S, there's T. The plane that contains all 3 of those is this creamy color. And they intersect in, and this is our line notation, the line ST. So there's S, there's T. This line here is where they intersect. I always like to think about the intersection of 2 walls. So if you look in your corner, if you look at the wall to your left, the wall in front of you, they intersect at that line going up the edge of the room. Now, let's talk about non-collinear before we move to Postulate 4. So collinear, which is here, collinear means together on a line. So ready? Co, if we split it apart, co, together on a line. So these 3 points here are collinear. I can draw a line through them. Non-collinear not together on a line, these 3 points here are non-collinear. It's important that when we talk about our 3 points, like in naming a plane, that we distinguish between our collinear and our non-collinear, because you cannot define a plane with 3 collinear points. It has to be 3 non-collinear points. And again, it's a lot of vocabulary, but most of it makes sense if you break it apart. All right, postulate 4, and that will be the end of this video. Through any 3, there's that word again, non-collinear, not together on a line. Through any 3 non-collinear points, there's exactly 1 plane. So that's why we name our planes like that. So R, T, and S, I cannot draw 1 line that goes through all 3 points, so they are non-collinear. So we can say that our points R, S, and T are non-collinear. And here's the other way you can name a plane, a capital kind of cursive letter. So plane V is the only plane that contains them. And I do realize here that I misspelled there. So contains them. Ignore the T. I was trying to erase it, but I chose the wrong tool. Okay, that is it for our first video. We will continue talking about postulates over the next couple of weeks, and then we'll move into some theorems and some proofs.